Smallpox killed more people in the 20th century alone than every war of that century combined, an estimated 300 to 500 million lives. And yet today, smallpox does not exist in nature anywhere on Earth. It is the only human disease modern medicine has ever completely erased. Not controlled, not managed, erased. For most of recorded history, that would have sounded impossible. Smallpox was not a rare killer, it was one of the most reliable ones humanity has ever faced. It helped topple the Aztec and Inca empires within a generation of first contact with Europeans. It was endemic on every inhabited continent. In the case of the ordinary form of the disease, it killed roughly 3 out of every 10 people it infected, and of those who survived, about a third were left permanently blind. Almost everyone who lived through it carried the scars for the rest of their life, literally. To understand how something this old, this deadly, and this universal simply vanished, the story doesn't start with a vaccine. It starts with a mummy. In 1898, archaeologists examining the mummified remains of the Egyptian pharaoh Ramesses V, who died around 1157 BCE, found raised pustular lesions across his face and body. To this day, it remains the oldest physical evidence of smallpox ever found, a disease already old enough to have killed a king 3,000 years ago. Ancient Chinese and Indian medical texts describe illnesses that closely match its symptoms centuries before anyone had a word for a virus. And because nobody understood contagion, every civilization that encountered smallpox arrived at some version of the same explanation. The gods were angry. Ancient Egyptian religious texts linked pox-like afflictions to divine punishment. In China, people prayed to Tushen Nyang Nyang, a goddess specifically associated with smallpox. In India, entire communities worshipped Shitala Mata, the cooling mother, in the hope of being spared. Among the Yoruba people of West Africa, the god Sapona was believed to control the disease directly. Cultures that never made contact with one another still landed on the same idea, because it was the only explanation available. Something unseen and angry was doing this, and the only defense was to appease it. But buried inside that same uncertainty was something remarkable, a piece of real working medicine, discovered empirically centuries before anyone understood why it worked. In parts of China as early as the 15th century, healers had noticed that people who survived a mild case of smallpox never caught it again. So they began deliberately grinding the scabs from mild cases into a powder and blowing it into the nostrils of healthy people, hoping to trigger a survivable version of the disease instead of leaving it to chance. In India, the Ottoman Empire, and parts of Africa, a similar practice took hold using a small scratch in the skin instead, a technique that came to be known as variolation. It worked often enough to matter. It also killed roughly 1 or 2 out of every 100 people who underwent it because it was still deliberately giving someone smallpox. For centuries, this trade-off, a small, calculated risk of death now against a much larger risk of death later, was the best defense the world had. Everywhere variolation hadn't reached, the response to smallpox stayed almost entirely superstitious and often actively harmful. In medieval and early modern Europe, physicians practiced what was called red treatment, wrapping patients and even the walls and bedding around them in red cloth based on the belief that red light itself could draw the disease out of the body. It was recommended by court physicians and used on royalty. Elsewhere, standard treatment involved bloodletting patients who were already critically dehydrated from fever, inducing vomiting, and lancing pustules in ways that frequently spread the infection further rather than containing it. None of it worked. All of it was applied with total confidence. The worst chapter, though, wasn't ignorance. It was what happened when smallpox met people who had never been exposed to it at all. When European colonizers arrived in the Americas in the 16th century, they carried smallpox to populations with zero prior immunity, and the results were catastrophic in a way war alone never could have achieved. In 1520, a smallpox epidemic tore through the Aztec capital of Tenochtitlan, killing the Emperor Cuitlahuac within months of him taking the throne, along with tens of thousands of his people. Historians now widely agree that disease, more than Spanish weapons, was what actually broke Aztec resistance to Hernán Cortés. Across the Americas as a whole, smallpox and the other diseases that arrived with colonization are estimated to have killed the vast majority of the indigenous population over the following century. And in at least one documented case, the disease was turned into a weapon on purpose. In 1763, during the siege of Fort Pitt, British officer Simeon Ecuyer recorded in his own journal giving blankets and a handkerchief from the fort's smallpox hospital to representatives of the Delaware people, in correspondence that his superior, General Jeffrey Amherst, had explicitly encouraged as a way to extirpate this execrable race. It is one of the earliest documented attempts at biological warfare in history. The turning point didn't come from a laboratory. It came from paying attention to something ordinary people already knew. In 1717, Lady Mary Wortley Montagu, the wife of the British ambassador to the Ottoman Empire, watched Turkish women in Constantinople perform variolation on local children as a routine accepted practice. She was so convinced by what she saw that she had her own son inoculated on the spot, and when she returned to England in 1721, she pushed to have her young daughter publicly inoculated as well, specifically to prove to a skeptical English public that the practice was safe. It worked, and variolation began spreading through Britain decades before anyone had heard the word vaccine. The real breakthrough came from a country doctor in rural Gloucestershire named Edward Jenner, who had noticed something the local farming community treated as common knowledge. Milkmaids who caught cowpox, a much milder disease that spread from cattle, seemed to never catch smallpox afterward. Their skin stayed clear while everyone else's was scarred. In May of 1796, Jenner decided to actually test it. He took material from a cowpox lesion on the hand of a milkmaid named Sarah Nelmes and used it to inoculate an 8-year-old boy, James Phipps, the son of his gardener. Phipps developed a mild fever and recovered within days. Weeks later, Jenner did something that would never be permitted today. He deliberately exposed the boy to material from an actual smallpox case to see if the cowpox exposure had protected him. It had. Phipps never developed the disease. Jenner repeated the experiment on other subjects to confirm the result, then tried to publish his findings with the Royal Society, who rejected the paper for lacking sufficient evidence. Jenner published it himself in 1798 under the title An Inquiry into the Causes and Effects of the Variolae Vaccinae. The Latin word for cow, vacca, is the reason every inoculation against every disease is still called a vaccine today, regardless of what it's actually made from. The public reaction was not immediate trust. A famous 1802 cartoon by the caricaturist James Gilray depicted newly vaccinated patients sprouting small cows out of their bodies, mocking the fear that the treatment would somehow turn people bovine. But within about a decade, vaccination had spread across Europe fast enough to cross wartime enemy lines. Napoleon, at war with Britain for most of that period, had his own troops vaccinated and publicly credited Jenner's work, even while the two nations were actively fighting. Getting the vaccine to Europe was one problem. Getting it across an ocean was another, because there was no refrigeration and no way to ship a living virus over weeks at sea without it dying in the vial. Spain's solution in 1803 was as strange as it was effective. The Spanish crown organized what became known as the Balmes expedition, led by royal physician Francisco Javier de Balmes, to carry the vaccine to its colonies across the Atlantic and Pacific. Their method was to use 22 orphaned boys aged 3 to 9 as a living cold chain, inoculating one boy with cowpox, then transferring fresh material from his arm to the next boy's arm roughly a week later, and repeating the cycle in a relay for the entire voyage, so there was always an active infection on board to harvest from on arrival. The expedition reached Puerto Rico, Venezuela, Mexico, and eventually crossed the Pacific to the Philippines and China, vaccinating hundreds of thousands of people along the way and training local doctors to continue the practice. It remains one of the largest international public health missions ever carried out, executed decades before germ theory existed, using nothing but orphan children as biological couriers. Acceptance was never total, and it never came quietly. As governments began making vaccination compulsory through the 19th century, Britain's Vaccination Act of 1853 was one of the first to require it by law for infants. Organized resistance followed almost immediately. Groups like the Anti-Vaccination League argued the state had no right to mandate a medical procedure, and in 1885 an estimated 100,000 people marched through the streets of Leicester, England, in protest against compulsory vaccination laws. The science was already sound by then. The argument was never really about the biology. It was about trust and control and who got to decide, the same argument that resurfaces almost word for word every time a new vaccine is introduced today. What Jenner could observe, he could not fully explain, because virology as a field didn't exist yet. We now know that smallpox is caused by the variola virus, part of a family called orthopox viruses, spread mainly through respiratory droplets and contact with contaminated material. After roughly 12 days of incubation, patients developed a sudden fever, followed by a distinctive rash that started in the mouth and on the face before spreading to the arms and legs. The key clinical detail doctors still use to identify smallpox in historical records is that every lesion on the body progressed through the same stage at the same time. Flat spot, raised bump, fluid-filled blister, then pus-filled pustule, all in sync, unlike chickenpox where new spots keep appearing in scattered waves. And the reason cowpox protected against smallpox turns out to be exactly the kind of thing modern immunology explains easily. The two viruses are close enough relatives that the immune system, once trained to recognize one, can recognize and destroy the other. Jenner had discovered cross-immunity by observation, roughly a century and a half before anyone could explain what an immune system actually was. Modern epidemiologists also point to something else that made smallpox uniquely beatable compared to most other infectious diseases. It has no animal reservoir. Diseases like influenza or Ebola can hide and mutate in birds, bats, or other wild animals, giving them an endless place to survive even after human infections are controlled. Smallpox only ever lived in humans. It also gave itself away. The rash was visible, distinctive, and impossible to hide, and unlike many viruses, an infected person generally wasn't contagious until the rash had already appeared, which made contact tracing far more effective. Every chain of transmission had a visible link. That combination, nowhere to hide and impossible to spread silently, is exactly why the World Health Organization's strategy of tracking down individual outbreaks worked as fast as it did. The scale of what smallpox did before any of this existed is hard to overstate. In 18th century Europe alone, it was killing an estimated 400,000 people every single year. The World Health Organization's later estimate, 300 to 500 million deaths in the 20th century alone, makes it, by most counts, one of the deadliest single causes of death in human history, ahead of every war and every other epidemic of the modern era combined. Roughly 3 in 10 people who caught the most common form of the disease died from it. Among survivors, permanent blindness affected around a third, and deep-pitted scarring across the face and body was close to universal. For most of human history, surviving to adulthood without some visible mark from smallpox was the exception, not the rule. The disease did not spare power either. England's Queen Mary II died of smallpox in 1694. The Holy Roman Emperor Joseph I died of it in 1711. Russia's Tsar Peter II died of it in 1730 at 14 years old. France's King Louis XV died of it in 1774. Crowns, armies, and palace walls offered no protection at all. The burden was never evenly spread either. By the middle of the 20th century, before intensified vaccination campaigns took hold, India alone was recording hundreds of thousands of smallpox deaths a year and accounted for a large share of all global cases, with similarly heavy tolls across sub-Saharan Africa and Southeast Asia. Wealth and geography changed the odds of exposure, but never the underlying biology. Once infected, a king in Versailles and a farmer in Bengal were dying of the exact same disease at close to the exact same rate. The eradication effort that finally ended this took the better part of 2 centuries to complete, but the final push moved fast. In 1967, the World Health Organization launched the Intensified Smallpox Eradication Program, led by the epidemiologist Donald Henderson, combining mass vaccination with a strategy of aggressively tracking down and containing every single outbreak the moment it appeared, rather than trying to vaccinate the entire global population at once. It worked faster than almost anyone expected. The last known case of naturally occurring smallpox in the world was recorded in 1977 in a hospital cook in Somalia named Ali Mau Malin, who survived and went on to spend much of the rest of his life working on public health campaigns. On May 8, 1980, the World Health Assembly formally declared smallpox eradicated, the first and to this day the only human disease ever deliberately erased from existence. There is one grim postscript. In 1978, a year after the last natural case, a photographer named Janet Parker, working in a building above a smallpox research laboratory at the University of Birmingham, was accidentally exposed to the virus through a ventilation fault and died. It remains the last recorded death from smallpox in history, caused not by nature, but by a containment failure in a lab that was supposed to be one of the last places on Earth still holding the virus at all. Today, routine smallpox vaccination has been discontinued almost everywhere, because the risk it once protected against no longer exists in the wild. The United States stopped routine vaccination in 1972, ahead of the global declaration once the domestic threat had already disappeared. By most public health estimates, ending smallpox permanently saves the world well over $1 billion every year that used to go toward vaccination campaigns, quarantine measures, and outbreak containment. Only 2 declared official stockpiles of the live virus remain on the planet, held under high security at the Centers for Disease Control in Atlanta and the Vils Institute in Russia, kept officially for research purposes and the subject of ongoing international debate about whether they should finally be destroyed. Put the 2 eras side by side and the contrast is almost impossible to process as the same species living through it. Before 100,000 deaths a year in Europe alone, a disease so common that scars from it were simply what most adult faces looked like, a death toll among children so routine that surviving to adulthood unmarked was treated as fortunate rather than expected, and monarchs dying from it in their own palaces with the best medical care their era could offer. After 0 natural cases anywhere on Earth since 1977, 0 deaths, 0 new blindness, 0 new scarring, a disease that used to kill nearly a third of everyone it touched now exists only in 2 guarded freezers, studied instead of feared. None of that means the story is fully closed. Smallpox has no animal reservoir, which is part of why eradication was even possible. There is no wild population of the virus hiding in another species, waiting to spill back over, the way there is with several other diseases. But the virus itself still exists, physically in those 2 secured labs, and biosecurity researchers continue to treat any scenario involving its accidental release or its deliberate recreation using modern synthetic biology as one of the most serious risks in the entire field of public health. Eradication didn't erase the virus from the universe. It moved it into a vault and left the door under permanent guard. What actually beat smallpox was never one single breakthrough. It was Chinese physicians centuries ago noticing that a mild exposure could prevent a lethal one. It was a diplomat's wife who brought a foreign medical tradition home in her own memory and insisted her own children go through it in public to prove it was safe. It was a country doctor who took a piece of farmhouse folklore seriously enough to actually test it rather than dismiss it. And it was, finally, a century and a half of imperfect, uneven, often politically difficult global cooperation good enough to track down and extinguish the very last ember of a disease that had been burning through humanity for at least 3,000 years. It is the only time in history our species has looked a disease directly in the eye and simply removed it from existence. Every other disease this channel covers is still out there, right now, still being fought. Smallpox is the proof that the fight is not unwinnable.